you doing? Good. I'm glad. Okay, I'm going to expect a little more like cheering at the end, especially when you're done with me, but I'm not done with you just yet. Let me go back to my slides. There will be no fancy animations. They're just going to be you looking at Keynote. So, hi, I'm Huyen Tue Dao. I am an Android developer, not too surprising given where we are. And I am a fanatic about custom layouts. I have been since Views, but now I am even bigger fanatic now with custom layouts in Compose. And so if you're in this room, I'm going to assume that you're interested in them, and I don't have to convince you. But I will like to say that, just like everything else, custom layouts, as much as I would wish it to be, is not a golden hammer. You shouldn't use it every single time you are, creating a UI in Compose. But I have learned in a couple years things that I like to, kind of basically warning signs. I would call them red flags, maybe like yellow flags, pink. I don't know, some kind of less alarming color that will allow you to know kind of maybe when you might need a custom layout. So the first one of these is whenever you have a screen that's made out of like heavily nested out of the box components. So one of the really nice things, and can you all see this okay in the back, readability wise? Like give me a thumbs up in the back. It's all right? All right. I guess shout at me if you can't see anything and I'll try to like bump up the resolution for you. Okay, so the really nice thing about Compose is that we have all of these, wonderful out-of-the-box components. And in a lot of ways, we can make layouts the same way that we speak. I can just describe to you, hey, I've got this form. It's kind of like a column of vertically, laid out components. But maybe this row in my column is a row that has its own little kind of subset of columns. And then this one has like a radio group, so that's going to be horizontal layout. So a lot of, the kind of anxiety about doing custom layouts in Views before was it because it was really hard. But sometimes we needed to because of performance. So it's like a kind of had to thing. That's kind of how I learned how to do it. Duress, great way to learn things. But with Compose is much more naturally performant. So we don't have to worry about that thing. So we have gotten used to this kind of nice, relaxed atmosphere where we can kind of nest things and not worry so much and not have someone like me come in and be like, no, don't nest things because linear layout and multiple passes and all kinds of stuff like that. That's more in the past, but I would still argue that if you're really nesting, if you're getting that like Christmas tree brace thing going on down there, that it's kind of worth considering, maybe not necessarily for your code's performance, but for your own and for your teams to consider like different options like subcomposables or custom layouts. So even though that this is, individually, each platform container is pretty easy to understand, in aggregate, it starts to get a little more complex, right? Like if I just look at this, like just quick glance at it, I don't actually know what this looks like, right? I have to kind of go through, hopefully there's a preview, maybe I can run the app, but it's really hard to parse this just looking at it. And not only that, it becomes less maintainable. The more and more and more you nest things, those inner children have all these different, kind of nested and connecting and cascading layout logics that might make maintainability kind of different. Someone changes something on an inner child or someone changes something in a middle child and things just kind of like cascade into, I don't know what's going on here. What's this bug? What layer it's at? So even if you don't have any performance problems, you might find that, hey, I might try to find a different organization or try custom layouts. And one that has come up a lot for me in like very recently and has become one of my pet peeves is if you find yourself using the on globally positioned modifier and some state to capture the width and height of one component to measure or size to measure size or lay out another component, you probably shouldn't do that. You might need a custom layout. You might just need a box with layout. Okay, I'll actually play a slide. I hope this works. So I know that we've seen code like this a lot, and it makes a lot of sense, right? So sometimes with your existing modifiers, if you have some really weird sizing or positioning, you just can't quite do it in a way that you're okay with. So you might do something like this, where, okay, I call on globally positioned on by column. I'm going to grab its width, and I'll use that width in a calculation to say, I don't know, for some reason, designer wants this component to be in a third of the size. I don't know why. So this also applies to if you're using the on-sized chain modifier. So why is this bad? So what you're doing is basically on initial composition, this layout can't render completely, right? Because it's dependent on the column fully laying out and then going back into the next cycle, the next frame, and then letting that some component know, how big it actually needs to be. So that doesn't sound bad in theory, but it's inefficient. And for certain things, and this actually happened to me at work, is that for certain things, say you're using the paparazzi screenshot library, which is an awesome freaking library, you should use it, and J-Rod made it, and he's awesome. Paparazzi, when it does its screenshots, it does it on initial composition of a composable. So if you have something like this in your layout, you can't really use paparazzi. You get a blank screen. It literally happened to me. And so, that's kind of a more pragmatic thing, but it's pretty inefficient. And if you actually go into the documentation on, Android developers on Android or whatever, the Android developer docs, I can't remember the URL right now. They actually do talk about this, and they have a much smarter phrasing for it, cyclical phase dependency or recomposition loops. And it goes into detail about, why this extra frame happens and why it's bad. And there's a really long quote that I'm not going to read to you. But the idea is that, we're in Compose right now, we're really getting into these like really kind of modern practices of UI, right? UI, creation. And we're doing like UDF, where we've got these like streams of hopefully immutable state that we're trying very simply to just reflect in our UI, right? We've got these single sources of truth, these single streams. And that philosophy you can see also reflected here, because this long quote is basically trying to say, okay, when you do things like this, you're creating more than a single source of truth. The idea with these layout primitives and with custom layouts is that the layout itself should be a single source of truth for how its children should be laid out and measured. And so now when you introduce that convenient state variable that holds something for you and you can slot it in, you're adding another source of truth and you're kind of mixing the water a little bit, right? And this becomes a lot harder rather to debug, to trace, and you're breaking that. So single source of truth, just remember that. But I mean, if you want just a plain old, reason, the doc said it's a bad thing to do. And there's always like alternatives. One really good alternative that you could just use and leave my talk if you want to, I won't feel too bad, just 50% bad, is box with constraints, which does actually pass, the width and height of that box to its children. Or the reason for you're here is custom layouts. So, why are we here? Well, custom layouts. So before we get to the actual coding, and I'm going to code for you, hopefully, we got to talk about life cycles because everybody loves life cycles. At least we're supposed to love life cycles as Android developers. We did have a view life cycle back in the day, but now we have compose phases. So there are 3 phases in turning your composable functions from those functions to renderings on the screen: composition, layout, and drawing. So what do these 3 things do? So composition is basically those composable annotated functions that we're writing. Those are actually invoked. They're read and invoked, and when they're invoked, they emit a thing. They emit a node. They create an emission, however you want to call it. And these nodes are representations in memory of each of those composables, and they start kind of building together into this hierarchical tree, right, of your container and the container's children and their children and so on and so forth. So it creates this UI representation of this tree representation of your UI, right? So it really is just determining what shows up on the screen. All right, so this composable, when I run it, I've got a row, I've got 2 radio buttons, and I've got 2 texts. Literally, that's it. Nothing about where they go, nothing about how they're sized. That's it. That's composition. So how big they are and where they go, is done in layout. And layout has 2 parts. It's a phase with like 2 little mini phases. There's measurement. So for this layout, during measurement, it's going to measure all of its children, and based on those measurements, measure itself. Something to note, and that will come around later, is that you can only measure a kind of node or emission once per frame, once per cycle. Okay, after we got them measured, now we can place them, and then elements place themselves or place their children rather, and end up on the screen somewhere. And then drawing happens where all this gunk gets drawn into pixels of the screen. We're not really going to worry about that too much. Now, what's really cool about Compose is that, again, we're in this like modern, more modern rather, Android development phase where, we're talking about Compose, and a lot of our everyday Compose, development is talking about state and what I've been referring to as state hygiene. Where should state be read? How much state should be read? Where should be hoisted? Like, how do we, cover what we need without exposing too much and reading it at the wrong time? Now, that's a lot of burden on us. But if we actually think about this, there's a lot of really cool benefits that Compose provides to us if we follow rules, but we follow the flow, like the way that Compose is dancing with us. And there's something called phase state reads. So for each of these phases, for each of these kind of sections of logic that I'm executing, I'm going to probably have to read some state, right? I might have some state that says, hey, show this switch or show this button or not show it. In layout, I might have something similar to before where, I might have, a preset size, or I might have some kind of density or some other state that I'm reading to determine like how big something is. And similarly, some kind of state to determine where the placement is. Now, what's really cool is that Compose is able to say, okay, I know you need this A object or A state for composition, and I know that you need some, say, B state for layout. If, for example, B changes, whatever my layout and so my measure and my placement need, if that state that is needed by, say, layout changes, but the state that goes in composition doesn't change, it doesn't do this entire process over, it'll actually skip composition, and that's phase state reads. It's very good about knowing exactly what state is read in exactly what phase, and skipping phases, and any of these phases could be skipped based on the state. And so what I think is so cool about custom layouts in Compose is that the best practices and the things that we're thinking about now, even in just everyday everyday kind of Compose use, applies even at this really deep level. So all of your good habits with your state hygiene, all that good state hygiene, it will apply when you dig down a little bit deeper. So what we're going to do today is we're going to do a custom layout. There's a lot of different ways of kind of customizing layout. There's like a modifier, but we're going to use this layout, or composable rather, called layout. There's a content parameter, modifier parameter, not too unfamiliar, and something called a measure policy. And so we're going to spend a lot of time in content and measure policy. So what I think is really cool is that, kind of not unfamiliar to the view system if you're used to it, you can actually see these phases very distinctly, or at least the composition and layout phases. You can see them super distinctly in this layout composable. So again, I mentioned composition is where you tell Compose what you are rendering, what's going to show up. And so that is very simply your content. So usually, the content is in a lambda that's outside the parentheses, at least as far as lint will want you to do. And, it's some composable function that when run emits that tree, that UI memory representation, that collection of nodes that represents the things that will be shown. And so those things that will be shown, now that you've decided what they are, become measurable. And so in measurement, you are given some measurables. So these measurables is a list of those nodes, those children that have been kind of returned when you invoke your composable function. And so with your measurables, what do? Well, you measure them. And then what happens is once something has become measured, it's been sized, it can now be placed. So it becomes a placeable. And in terms of placement, you can see where the placement phase happens, because every time you have a layout like this, you have to, in the measure policy rather, you have to at the end call this layout function. It's not too different from an on layout where you had like a similar function that was required and it'll crash or the compiler will yell at you. The same thing. So within that lambda, inside that block, inside that lambda in the layout is your placement phase. That's where you're going to be laying stuff out with the X and Y coordinate. So, do you want to build a schedule? Because that's what I have done at many different projects. Many different projects. For some reason, I've had to work on UI where I have a bunch of different items and I'm laying them out, chronologically. So they're kind of like mapped to time on the x-axis, right? And I've had to lay them out horizontally. Gantt charts, like video editors, so many things are schedules. And so I've built this many times and I've come across this actual problem many times. So how could we build a schedule? So I'm going to try to get out of Keynote, and I want to show you actually something similar to what I've built. So what we're going to do is we're going to build a schedule with classes. So I'm a big fitness nut. I love fitness classes. So what I'm going to do is I'm going to pretend for a minute, or maybe one day when I get time to build my $1 million app, it's not going to be that much, I'm going to build a fitness class app, right? And so I have these session, composables. They have a date, they have a time rather of the start and end of this class, the name of the class, the location of the class, the yoga studio, boathouse, the dojo, the main gym floor, whatever. and the instructor and possibly the instructor's image. So now I'm going to run this app as it is. Okay, actually, we're going to go in and see. This is live, so you get to see you shuffle around and inside of, okay, in here. Okay, so now we're just going to disable this just for a minute. And I'm just going to show you kind of the basics of, and kind of almost like a post-mortem forensics of kind of where I personally, as a developer, came to in terms of like implementing this schedule component. So kind of starting from my beginnings and kind of the phrase I first figured out to now. All right, running devices. Please work. Please compile.
Oh.
It's fun because it's live. Come on, baby. There we go. All right. Okay. So I have a couple of different implementations here. So horizontal list of things. Well, that's a row, right? And here's my row. And as you can see here, it's running my sessions. So a couple of things about this. So what's kind of interesting about row is that it really just lays things out one after the other. You give it a list of composables, and it lays them out consecutively. Now, if you look at the data, actually, I'm going to change the data real quick. Sorry, and we're going to run it one more time. Now, so that kind of works if I have a schedule or some kind of like, time, kind of like time-dependent data. That works if if things are happening one after the other. But, not everybody is using, the Yoga Studio constantly, like, one every second of every day. There might be gaps in the schedule. And as I just said, Row doesn't actually, it does do spacing, but it doesn't do arbitrary gaps per se. So what's the best way for me to use Row to implement this? Well, what I could do is do something like this where, I actually have a row, and what these are, and I can show you the implementation. Here we go. And here, we'll go up. So this is kind of like a very first pass draft. Can you all see that okay in the back? Thumbs up, code okay? Okay, thank you, darlings. All right, so here we have a row-based implementation, right? So I have a row, I have the kind of very start of the schedule, just whatever, when the gym opens, and I'm creating spacers. So anywhere I have a gap, I can use that start end time to figure out, okay, here's where an actual session is, here's where a gap is, and if it's a gap, it's a spacer. If it's an actual class, then I get my session composable here, which you can see right here, which I showed you earlier, and that's it. And then, of course, I have all these tracking, to kind of process through and kind of get the gaps, stuff like that. That's really great. Okay, cool enough. All right, if we go back, now this works just fine. I have it scrolling. I also have this DPs per minute slider. So imagine if you wanted to zoom in, zoom out on a schedule. This is DPs per minute. So basically, based on how long something is and how many pixels I want to draw per minute, I can actually zoom in and zoom out, which is kind of cool. All right, now, it seems cool, but let's take a look at the layout inspector. So layout inspector now has a wonderful recomposition counter. So again, I don't want to encourage anyone to super hyper optimize all the time, but it is good to note, especially when you do, it's good to know what to do when you do run into performance problems. So what I will show you though is that, okay, if I'm scrolling around, I don't really see any compositions. Oh dear. Here, let me run that again. That is not helping. This is live. Okay, we'll do this. There we go. All right, layout inspector. Okay. As you can see, as I'm scrolling around, you're not really seeing much in the way of recompositions. And that makes sense, right? Because when we're scrolling, we're just changing placement. We're not changing what's on the screen. So I wouldn't expect to see any recompositions, right? Now, say I decided to, and let me kind of drill down to my row track. Here's the row that makes up the track. Now, if I move the DPS slider, though, oh, shoot. These are composition counts, and you can see they're just not stopping. It's just every single time I move that slider. Okay, why is that happening? Why is it that scrolling doesn't recompose, but changing the zoom does? And it really shouldn't. Especially depending on how much I zoom, the sessions on the screen may or may not change. But they shouldn't be changing that much, right? So what's happening? So what is happening is if I go to here, so DPS per minute is a parameter into my composable. So when that parameter changes, that is going to trigger a recomposition. Now the question is, can it be skipped? So the problem is that the way that I've implemented this, right? I'm using this DPS per minute here in the content. What phase is this? It's composition. And as we went to phase state reads, because that state that is in composition is changing, well, it has to recompose. And so that is the problem sometimes with doing this kind of logic in, a regular composable, because, in row, in column, minus a couple modifiers, you really can't reach in and put and kind of put the state where we need it, right? We generally only kind of are at this level. So that's kind of the power of custom layouts to get in there. And I mean, I guess you could use lazy row, but I can show you also that lazy row as well down here. Also, so what you can see here from the light inspector is cool. That is cool is that it is only rendering, the sessions that are off screen. Anything that's out of bounds doesn't get rendered. But I mean, the composition count, y'all, is not good. So, and also another thing that's really interesting that I ran into when trying to do this with lazy layout is, you see how like I'm trying to make the tracks as big as the tallest item. If I actually, let's make this really tall and really awesome. So let me see. Oh wait, hold on. Here we go. We'll do this. So you can see here that because the off-screen ones aren't being composed, when they actually come into view, you can see like down here, the height of that is actually changing because, right? So these are the kind of things that you run into with out-of-the-box stuff. It's that kind of edge case. It's that we love you designers, annoying thing the designer asks you to do, and it doesn't quite fit the out-of-the-box components. So what can we do? Well, I will show you what we can do. We can go to our schedule screen. We're going to let's get rid of this one. And we're going to use a version of that track, that horizontal layout that is based on layout. Okay. And back here. Okay. So here's my, layout inspector does that. All right. So here is my two layouts. This one's the row still. This one is using that custom layout. So you can see here, it's a little janky because of the layout inspector, but it still scrolls. It looks like it's supposed to, renders the same. Now, if I go down here, all right, here's a real special thing. All right, can I see the composition goes through? So if I move this DPS slider, oh wait. Aha, okay, I was a little nervous there for a second. Okay, here. Now, so this is the actual kind of compositions, right? Here, let me open this so I'm not cheating. Okay, so in the white numbers are actual compositions. Okay, these are recompositions that haven't been skipped. Here is my layout track, and as you can see, even though this many recompositions were requested, the gray means that they've been skipped, and that's really awesome because that DPS was the problem, right? Because we were reading it in composition. If I go into my schedule layout track, we can see, okay, so here's the composition part. So composition kind of looks like any other content. I'm kind of iterating through my list of sessions. I've got my session, composable here that is that little, rectangular square of the box. And okay, I'm admitting that this is really kludgy and I'm going to fix this. But for now, in order for each session to kind of know its start and end time, I'm going to pass it the session data as a layout ID. Please don't fricking do this. I did this because I didn't know better at first. This is just like the OG days when we were just sticking everything in view tags. But we're going to do this for now, and I promise I'll fix it. Okay, so that's composition. This part, the content, that first lambda is going to be that composition where we tell what is being drawn. And that's exactly what we're doing here. Now, we're going to measure policy where our measurement and placement live. So let's go through this step by step. So measurement phase. So I'm actually taking that DPS per minute, changing it to pixels per minute. And because I'm being really kludgy and including the data object as an ID, this is what we got. So I've got my measurables that came from that column, that composition, that compose. All right, so I need to take each measurable. I'm going to pull out that session data that I kludged in there in the layout ID. I'm going to get the minutes. So that's going to tell me how wide something needs to be. And I'm going to use that information to measure each measurable. So I do that by first creating constraints. So about constraints. It's not too different if you are a OG view system person from the idea of like layout parameters and constraints in there. So constraints define the bounds or lack thereof of the dimensions of a measurable. So these constraints can define an unbounded width or an unbounded height or a bounded width or a bounded height or a fixed height and a fixed width. Yes. So if you look at something like these constraints, so constraints is this class, actually underneath it's a packed long where like the different bits stand for like the min width, min height, max width, and max height, yes. But there's a nice, not bit shifty API for this. So constraints are going to define 4 things: min width, min height, min width, max width, min height, max height. And it's either going to be, it can go anywhere from 0, and you cannot have negative dimensions, it will crash, or infinity. So in this constraint, which is actually kind of like the default parameters that you'll get when you just call this is both an unbounded width and an unbounded height. My width can be from 0 to infinity. So for bounded, you can mix and match, you can make them bounded. You have these constraints, for example, where it can be no smaller than 400 pixels in the width, but no bigger than 200 pixels in the height. And what we're going to do is actually use a fixed width. So I'm going to close this so we can see better. All right. So what we're doing for us is that we know exactly how wide these things have to be, right? So we can give it a fixed width. So I'm actually taking the constraints. These constraints are given to the parent. So what I'm going to do is I'm going to specify a fixed width, which I calculated from, again, the minutes of the session, the DPS per minute. And I'm going to copy the parent's constraints because that allows me to just kind of take in the constraints for the height and then override the min width and max width. And then what I need to do is actually pass these constraints into the measure function for each measurable. And then because I'm doing a kludge way, I'm actually pairing it with the session so I can create an array of the session ID, with the session data rather, that is like kind of corresponding to my list of measurables and placeables. Okay, so that is measurable. So what we get back from here is actually this list of placeables. So now that we've measured and now that they're placeable, we're going to place them. First, though, we need to calculate the content width and content height. So now that we know how big all of our children are to be, we need to know how big this track is going to be. And if you can see here, I'm basically taking the entire span of time that covers all the sessions and then calculating a pixel value out of that for my width based on the pics per minute. And then I'm doing, then with the content height, I'm just going to go back to that. Okay, we're just going to do the height of the tallest session rather. So that's the content width, content height. Now I'm going to feed those in, and I'm also going to constrain that height to make sure I don't, I don't actually know what the constraint heights are, but I just want to make sure that I follow them, whatever they may be. So here's the placement phase. All right, so I have a start time, which is more or less my 0, my x equals 0. And here I'm kind of just iterating through that kludge list of data objects, going through and mapping each session to an X value based on, its start time and what I know to be my reference, my reference time. And then all we have to do to place it is for each placeable that we got, just call either place or place relative. Place relative is RTL respecting. Place just does whatever the hell it wants, left to right. But as you can see, I feed into it X and Y, and that's it. So I know that seems like a lot more code, right? But it's very specific, and it does provide us this very intentional way of separating out where our state is meant to be. So I'd argue with you that rather than doing what I did and spend hours and hours trying to bend and break row and any other platform container to your will, this is not so bad, and actually it is very explicit. All right, so here's our latent intention. Oh, and it has that wonderful function, wonderful advantage of being, performant and being able to skip compositions. So, what am I going to show you all next? Okay, so I want to one up this lazy row. Ooh, sorry, those are my notes. Okay, I want to up that lazy row, right? It was pretty cool, but it couldn't handle, things at different heights. So let's see how we can make it so that regardless of regardless of the content and how high these things get, let me try to play inspector, that they can all be the same height. So I'm going to go back to my code, and I want to zoom out for just a second. So we're going to use something that you might have heard of, and that's called intrinsics. So first I'm going to switch out how I measure these things. So we're going to get rid of that. And I'm actually going to show you this. So what do we need for those sessions to be of the same height, right? So I need to tell you something, and that's a rule, that within one frame of that cycle, you can only measure each child once. If you measure more than once, you'll get a crash. So in Compose, in very big contrast to View World, measurement was kind of like just measuring it and then just seeing what it was. It wasn't a prescription. But in Compose, when you measure something, that is the size that is going to be. It is not just an observational process. It defines the size of that child. So, I mean, how are we supposed to do this if I can only measure things once, but I actually want the ultimate height of it to be something different? Well, you need to be able to get that information, and you can do that through intrinsics. So, intrinsics are basically methods that say, that are kind of intrinsic to whatever composable, and these functions allow you to say, hey, given this min or max width, how high will this child be? Or given this min or max height, how wide should this child would be? So it basically allows you to kind of anchor either width or height and then get the other one. Kind of based on the intrinsics of that composable, what should the other corresponding dimension be? So let me hide this again. I'm going to zoom back out and do some coding. Okay, so I'm going to uncomment Dios. Let's see, that's okay. I think that's all we need to do. Great. All right, so intrinsics, how do they work? So we're going to rearrange the code a little bit. I still have my session data in my layout that it can see everything in the session. Don't do that. And so here I'm changing around a little bit. I'm kind of separating out my widths, kind of like turning that session time data start and end time to a width here. And here I'm collecting intrinsic heights. So what I'm doing is that now that I know the width of each session, I can actually call this function min intrinsic height and say, hey, you measurable, if I give you this width, what height would you give me? And I can actually create an entire list of corresponding, heights to each measurable. And now nothing's been measured. We've just kind of taken a peek behind the curtain. So what we can do now is use those intrinsic heights, find their max, and then use that height to actually fix the height with fixed constraints. So we have fixed width, fixed heights, we measure them, and then the rest of it is honestly the same. And I'm going to run it and show you what we got here. Go back here. And as you can see here, there we go. Okay. Ignore the top one. See the bottom one? Now we have everything the same height, regardless of like the DPs per minute. And even if they get really, really skinny, you can see they're all the same height. So that's another tool to have in your toolbox, intrinsics. So it's a way of pre-estimating, I guess, how big something should be. All right. Now, oh shoot, I got 7 minutes with y'all. Okay, so if we go back here, and I'm going to actually I'm going to change some data. So that was all really well and good for that schedule I had. It was a really chill schedule, not too many classes, nothing overlapped. What does it look like if our data does overlap? Yeah, not great. It renders great, but as you can see here, and I can, tap in and see what things is, this is not good. With that, oh, is it not? Oh, okay, my bad. Thank you. All right, there we go. Okay, my bad. So as you can see here, yeah, it renders, but that data kind of sucks. And also, to go back to the row, you can see why the row breaks down really fast here, right? You can see that it's just not reflecting the actual time of the classes. It's just laying things out one after the other. So how would we do multi-track? So the thing with multi-track is, okay, say that I wanted to just like break up my data. I'm going to just kind of split them off into different locations. And so I'll have a track per location. So now that kind of definitely has kind of alleviated the data problem. Now, what I need is for these tracks, and for this example, I'm going to go with rows. These are 1, 2, 3, 4, 5 different rows, right? How do I get them to scroll in unison? The way I first tried it, and it's the way that maybe you used not to try it, so tell me that, yes, you would have thought of this, so I feel less bad about myself, is to actually share the scroll state. So what I did here is actually create a single scroll state, and you see here, this is the loop where I'm actually looping through each location and each session and each location, or rather creating a track for each location and then sharing that scroll state. So this scroll state is the same for each one of them. Now if I go back, what happens if I scroll? Oh, okay, that's not bad. Oh, I see. The overscroll only happens on the one that I'm touching. And not only that, the scroll state control also has a notion of how wide something is so that you don't, scroll past the content. And what's happening is, I think because this is the last one that got the scroll state, it's using this one's width. So if I have data that's larger than it, no dice, and of course, it's just a mess. So no, sharing scroll state doesn't work. And I actually asked Adam Powell on the Android team this, and he said, no, very specifically, scroll state is meant to be a single source of truth for a singular, scrollable, composable. All right, so are we screwed? No. All right. So, shoot, I'm running out of time. So this is Adam Powell. Thank you, Adam. So how about instead of doing scroll, we use the fact that we have so much control over the custom layout to do something cool. So here's like a representation of my track, right? So if the schedule is scrollable, a lot of times what happens is only part of it is visible, right? Let's go back and show you the text that I actually wrote. So whenever we're scrolling, whenever something is scrollable, we're only seeing a portion of it at a time. So instead of actually scrolling, let's call this a viewport. So rather than thinking, okay, I'm going to render my layout and have scroll offset it, like move it back and forth, how about I just say, hey, my component is just going to draw what's in the window. And so what happens is, rather than say scrolling an offset, what if we just take, so the left half is the start time, the right time is the end time of my viewport, right? It's a window. What if I just shift that window and move that start time? What's going to happen is it looks like the schedule is moving under the window, but what's actually happening is this. Like in the code, this is what's happening, right? But what people will see, like the users will see, is this, okay? So, oh my gosh, I only have 3 minutes left with y'all. I'm going to speed run this. So what I did was I actually created that in code. So there's a couple things that I really want to talk to you guys about before I go, and that is custom scopes and custom modifiers. So there's this idea, okay, so I have my viewport here, okay? It's a data class that defines that viewport. And what I'm going to do instead of scrolling is I'm actually going to shift that viewport. So I'm going to shift the start and end time to be within the bounds of this min and max. And then I've actually defined a bunch of methods that are really nice that I can shift things by some delta minutes. I can actually scale it from the middle using multiplication. And so this is all with a viewport. And so what I need is a central place for that viewport to be disseminated, not just to the schedule itself, but to each track. So what I need is a scope. So a scope is kind of a central object that holds data. If you look at your favorite classes like row, you'll notice that its content actually has this receiver called a row scope. That is that central object that is the single source of truth for that layout and its children. So I define that. I define my own custom or interface schedule scope. I say, hey, there's a viewport in this, and hey, I have this modifier that you can use in this scope, and any child that uses time range can say, hey, associate me with this start and end time so that you don't have to do the kludgy thing of putting an entire data object into your layout. And if I kind of dove in, if I just go into the implementation, what I've got here is this implementation. I've got viewport is actually a state, and I have this modifier time range using the modifier.node API. And if I actually run this again, let me see, that was the purple one, right? Yeah. So, yep, I got it. Thank you. So what I've got here is, hold on, let me make sure that I have it here. Okay. Scroll, okay. So what I have here is my viewport. And as you can see here, I've got my nice tracks. Each one shows each location, and it scrolls. And if we open up layout inspector, oh my gosh. Let's do it again. Sorry, real quick. I'll let you guys go soon. All right. Okay, there we go. It's back. All right, we can see that it's not quite as lazy as lazy row, but if we scroll around, we can see No recompositions happening. So how does the scroll work? So I have here my viewport. This viewport is actually stable, meaning that it will communicate to compose whenever it changes. So that way, even if this viewport changes, the scope instance stays the same. So the composition can be skipped. And what's happening is every time I scroll, I do some math to kind of bookkeep that scrolling. I use my shift function to shift that scope, that viewport. I assign it back into viewport. And then because that viewport has changed, it fires off measure and layout. And so I get my scrolling with no recomposition. And that is actually my time. I'm going to let you guys go. But I just wanted to show you just like really briefly, kind of like the power that you can do with a great abstraction and the power of custom layout. There's so many things you can do. You can add more custom modifiers, like you can actually make this like using a pan or a zoom gesture to kind of zoom in, zoom out. You can make these more reusable so that you can use them like a traditional layout. You can do all these things with custom layout. And you just have to get in there and remember the 3 phases, remember your good state hygiene, and you can do these really cool things and kind of have these really cool expressions where, you can have something that looks like it was made with like a scrollable, but it's actually a window, a cut into your schedule pie. But yeah, I will have all the code for this. The code will have actually a lot more of the advanced stuff that I didn't quite get to. Really quick plug while I have you. So I do a user-centric, a kind of consumer-centric podcast called Android Faithful. We talk about devices, we talk about news, we talk about apps, we talk about world news, legal cases that have to do with these things, and we talk about developer stuff. We talk about like whatever the latest release of Android is. We are actually here at DroidCon. We're going to do a live episode so you can see what we're all about in the podcast room. But yeah, come and check us out tomorrow 10:20. And yeah, check me out on my stuff, randomlytyping.com. That's me. And yeah, thanks for coming and try custom layouts.